Within our lifetimes, we have all been affected by storms and flooding. The results can be devastating. In 2005, Hurricane Katrina took over 1,800 lives and caused massive damage to the city of New Orleans. The powerful storm surge caused 53 levee breaches in the storm protection system, and 80% of the city became flooded. Even here in Texas, we are prone to flash flooding, where sudden and torrential rainfall can cause homes to be flooded in less than an hour. In 2013, over Halloween, Austin was subjected to intense flooding. Again, this is a threat to human safety and can cause irreparable property damage, the effects of which are still being mitigated several months later. It is in the best interest of society to find ways to prevent the loss of life and property. For this upcoming unit, we will investigate the question, how can we use calculus and engineering to protect people from flood damage? Although we cannot prevent tropical storms and hurricanes, civil engineers can play an important role in mitigating the impact of these disasters. If the engineers can model terrains and predict flood behaviors, they can help prevent devastation. In 2011, severe storms caused devastating floods in the city of Brisbane on the eastern coast of Australia. Civil engineers developed a simulation that ultimately predicted the devastation that would ensue. They used complex geographic information studies, or GIS, to accurately model terrains in computer software. The gradient vector provided the information to predict water flow and collection points. With modeled terrain and the information from the gradient vector, they were able to identify the areas that were going to be the most dangerous. In the future, these simulations can be used to facilitate the design of city planning and protection systems to help keep people safe. The process of using geographic information studies is very accurate, but also extremely tedious. Oftentimes, in order to arrive at a first-order approximation of a specific region, as indicated here, civil engineers will approximate terrains using mathematical functions. This process allows the engineers to easily approximate flood zones and drainage paths. This is all accomplished using the directional derivative, and, in particular, the gradient vector, both of which will be discussed in the upcoming videos. Additionally, these functions are also easily generated in CAD software and can be brought to life using 3D printers. The physical representation of the approximated terrains allows engineers to verify their predictions and also facilitates communicating the effects of powerful storms to the general public.